Hi, it's Professor Dickerson. I'm going to show you how to use simulation to estimate an interesting real-world probability. So in the card game Blackjack, the best hand you can receive is a blackjack, which consists of an ace and a card that's valued at 10 points. So this would include the 10, jack, queen, or king. So a gambler would naturally want to know, what's the probability of being dealt a blackjack? For this simulation, we'll assume we're using a standard 52 card deck. So here's what that 52 card deck would look like. We have 4 suits, and in each suit, ace up through king. All right, so for us to achieve a blackjack, we're going to need one of these 4 aces paired with one of these 16 cards, which are all considered 10 points in blackjack. All right, so let's assess the key properties of the situation and think about how we could translate that into a randomization simulation problem. Okay, so there's clearly 52 cards, and if they're shuffled well, they will all be equally likely to occur. We'll be dealt 2 cards at random, and this is without replacement, meaning you can't get the same card twice in one hand. After all, there's only one ace of spades in the deck, for instance. Now, the order of the cards in your hand doesn't matter. Whether you get ace then 10 or 10 then ace, it still counts as a blackjack. All right, and like we said, the blackjack is specifically an ace and one of those 10-point cards. So let's go to the randomizer. So this is randomizer.org. And set up our simulation. So how many sets of numbers do we want to generate? Well, remember the probability using the relative frequency approach is where we look at the long-term or long-run behavior. So we wouldn't be content to just do a handful of simulations here. We want to do many simulations. Now, a professional would probably do 10,000 or so, but then again, they'd also have a computer program to sift through the results. We're going to do a little bit more modest of a number here. I'm going to do 200. All right, how many numbers in each set? Well, this is going to represent our blackjack hand. So we're getting 2 cards per deal. So that's a 2. Next, well, how many are these 2 cards coming from? Like we said, there was 52 possible. And we do want each number to be unique because, like we said, this is sampling without replacement. You know, if once the ace of spades is dealt, you couldn't get it again. All right, finally, I am going to ask it to sort my results because, after all, the order doesn't matter. And if I sort the results, they're going to be a little easier to sift through. Okay, so before I press randomize, let's go think about what kind of results are we going to get. Well, we'll have 2 numbers, each number being somewhere between 1 through 52. Now, for a blackjack, we're specifically interested in an ace and one of those 10-point cards. So I'm going to signify that the aces are numbers 1 through 4, because if I sort smallest to largest, it's going to be easy to spot an ace immediately. So aces are 1 through 4. And then my second card, if I do find an ace, I'm going to want to be somewhere between 5 through 20. Now, you don't have to use this method. You could just label all the cards 1 through 52. It would just be a lot more tedious to sort through the results. Okay. All right, we have a lot of cards here that I didn't even bother to write the exact ID numbers on because they're going to just be represented by all the other cards in the deck, 21 through 52. So for our purposes, we don't really care whether we get a 7 or a 5. It's just junk. It's not going to help us get a blackjack. Okay, so let's go back and actually do the randomizations. Okay, so as desired, I have 2 cards in each set. And remember, I'm looking for specifically the first number to be an ace. So 1, 2, 3, or 4. Scroll till I find one of those. Okay, so here we go. 2. That's an ace. But then remember, for the blackjack, the second card would have to be somewhere between 5 and 20. So this one's too big. So we have an ace for the first card, but a junk card on the second. Not a blackjack. We'll keep going. Again, an ace on the first, but a junk for the second. Ace, junk. So as you might imagine, the casino wouldn't make very much money if blackjacks were happening all the time. But rest assured, we will find some of them. Okay, so here's one. 1 and 7. So I got the ace of clubs is the 1, and the queen of clubs, which is the 7. So that is a blackjack. So I'm going to keep a little tally on my notepad here. And let's find one more, and then I'll speed things up. Okay, 3 and 7. All right, so that was the ace of hearts and the queen of clubs again. So that's our second blackjack. I'm going to make a tally mark on my notepad. And this is going to be a little tedious. I'm going to go through the whole set of 200. So I'm going to pause for a second, and I will be right back. Okay, I'm back. I made it down to the bottom of my list, and I found a total of 12 blackjacks out of 200 simulations. So what does that mean? Well, that is our estimate of the probability of a blackjack. It happened 12 times out of 200 simulations for a proportion of 0.06. So I would estimate about 6% of the time you get a blackjack. Now, the true probability, if you look it up, is actually 4.8%. So I was not that far off. 0.048 would have been the true probability, and I got 0.06. So not too bad. That was only using 200 simulations. If I wanted to get a more accurate result, I would up that number and do maybe like 1,000 or 10,000. Okay. So I hope you learned something. We can solve interesting problems and problems that might not immediately have a clear answer using simulation. So thanks for watching.